Hey guys, so like I said yesterday, today we are building on the ACB method. We're really just adding like one or two extra steps to it. These types of polynomials are called ax squared plus bx plus c polynomials. The only difference is that all of the polynomials we dealt with in the previous lesson had no coefficient in front of the x squared or an imaginary one. But today we'll have actual coefficients in front of our x squared. That's the only difference. So this is lesson 3.6, factoring ax squared plus bx plus c polynomials. Of course, we are still using the ACB method. That's the method we're going to use for all of our different types of polynomials. So our first step is actually to look for a greatest common factor. And we'll do an example that includes a greatest common factor next, but you should always check for it when you have a coefficient in front of your x squared. So what we're checking for is to see, is there any number that we can divide 8, negative 18, and negative 5 by and get all whole numbers? And there's not. So there's no way to greatest common factor this. So then we just go into our normal ACB method. Step 1 is, of course, A times C. So that's our 8, our coefficient in front of our x squared, times our constant, which is negative 5. So that is negative 40. Step 2 is to find our factors of negative 40. So the different numbers that multiply to give us negative 40. So that would include, and again, the number that I'm eventually going to have to add to is negative. So when I'm multiplying these, the bigger number needs to be the negative one. So 1 times negative 40, or 2 times negative 20. You could keep going, but I know that I can stop here because 2 plus negative 20 is going to add to my b value, my negative 18, which is the next step. So I have found my factors that add to my b value. I'm now going to rewrite this polynomial, but replace the b value with my new factors. So 8x squared plus 2x, this is a positive 2, and we keep our variable. And then this is a negative 20, so minus 20x, again, keeping our variable. And then our constant stays the same. So again, I've replaced that negative 18x with the two factors that add to it, the positive 2 and the negative 20, and kept the variable. My next step is to divide my polynomial in half between those two factors. And then I'm going to look at each half of this polynomial one at a time and greatest common factor it. So 8x squared plus 2x. So first I'm going to look at my numbers, the 8 and the positive 2, see what the biggest number those can both be divided by is. And of course that's 2, so I'll take a 2 out. And then x squared and x, what's the largest number of x's I can remove from both of them? And of course that's just 1x because the 2x only has an x. So my greatest common factor is 2x. In brackets, I'll write what's left over. So 8x squared divided by 2x, I'll do 8 divided by 2 is 4, and x squared divided by x leaves me with just 1x. And then positive 2 divided by 2 is, of course, positive 1, and x divided by x will cancel out. I made that bracket too far away. Then I go to my second half, negative 20x minus 5. So I'll look at the numbers, negative 20 and negative 5. What's the biggest thing I can divide both of those by? And of course, it's negative 5. And since my constant here doesn't have an x, I cannot take an x out as a greatest factor. So my greatest common factor is just negative 5. Then in brackets, I'll write what's left over. So negative 20x divided by negative 5. Negative 20 divided by negative 5 is 4, and then I keep my x. And negative 5 divided by negative 5 is positive 1. My next step is to make sure that both of my brackets are identical, and they are, so I've done this correctly. I'm now going to write that bracket underneath. And then my second binomial is just going to be the two terms that were not inside the brackets. So the 2x and the -5. And then that's my final answer. I could, of course, check my work by expanding those or foiling them. Again, I'm going to start with my first term and multiply it by both terms in the second bracket one at a time. So 4x times 2x is 8x squared. 4x times -5 is -20x. Then I go to the second term in the first binomial, and it gets multiplied by both terms in the second binomial. So 1 times 2x is positive 2x, and 1 times -5 is -5. And then, of course, I have to actually add my like terms together. So that leaves me with 8x squared minus 18x minus 5, since -20x plus 2x is -18x. And now I have the same polynomial I started with, which means that my factors were correct. Okay, so anytime you're doing the ACB method and your A value is something other than 1, so you have a number in front of your x squared, you should always check if your polynomial has a greatest common factor. So that's actually the first step. Check to see if our polynomial has a greatest common factor. So we're going to be using the example 9x squared minus 12x minus 21. If we look at 9, -12, and -21, we should see if there is a number that we can divide all of those by. And there is. They're all divisible by 3. So I am going to take out a 3 as my greatest common factor and then write what's left over. So I'm removing my greatest common factor, which means I have to divide my original polynomial by that factor. So 9x squared divided by 3 leaves me with 3x squared. -12x divided by 3 is -4x. And -21 divided by 3 is -7. So I have removed my greatest common factor, that's 3. Then it says just factor the remaining polynomial using the ACB method. So I'm actually going to take this 3, my greatest common factor, and put it way off to the side. I'm going to ignore it completely for now while I use the ACB method to factor the polynomial that's in brackets. So I'll go off to the other side and, like always, do a times c. So the number right in front of my x squared is 3 times my constant, which is -7, gets me -21. Then, of course, I have to find my factors of -21, which includes 3 times -7. And I don't have to look and see if there's any other factors because, lucky for me, 3 times -7 is going to add to my b value, the number right in front of my x. 3 plus -7 gives me -4. So now I'm going to keep my 3x squared. I am going to replace that center term with my new factors. So a positive 3x and a -7x. Remember, we keep our variable with both of them. And then my constant stays the same. Then, just like always, I'm going to divide my polynomial in half and factor each half separately. So 3x squared plus 3x, they both have an x, so I'll definitely be removing an x. And they're also both divisible by 3. So I'm going to take out a 3x, and in brackets, I'll write what's left over. So 3x squared divided by 3x. Well, 3 divided by 3 is just 1, and x squared divided by x leaves me with an x. And then positive 3x divided by 3x. Well, positive 3 divided by 3 is positive 1, and x divided by x cancel out. So that's what I'm left with there. As we go over to the other side, this time only one of them has an x, so I won't be able to take out an x as my greatest common factor. Negative 7 and negative 7, both of those are divisible by negative 7. So that's what I'll take out as my greatest common factor on the second side. And then in brackets, I'll write what I'm left with. So negative 7x divided by negative 7. Well, negative 7 divided by 7 is 1, and I'll keep my x. And then again, negative 7 divided by negative 7 is positive 1. Next, I have to double check that my two brackets are the same, and they are, so I can write those out. 1x plus 1, or just x plus 1. And then the two things that were on the outside get put in my other bracket, 3x minus 7. And then I'm just going to bring this greatest common factor that I've been ignoring back and put it in front of both of those. And that whole thing is my final answer. Okay, so always make sure that you're double checking for that greatest common factor before you do the rest of your ACB method. And just plop it off to the side, put it back in later if you need to. Let me know if there's any questions.